we've got here is from where a box is being dropped and it's hitting the floor, and obviously stopping that hits the floor. But it's a little bit strange because the science they're checking here is what I normally call crash science, where you're looking at a car going into another car or going into a tree, and you're looking at the change in momentum, how quickly the momentum of that car changes, and therefore sort of what forces are on the driver. So here the curve is sideways. We haven't got a car hitting a tree, we've got a box hitting the ground. But there are clues there that this is still crash science, because it says the box hits the floor and crumples a little. And hopefully that clue makes people think, oh, crumples, as in crumple zone. So the crumple zone in a car is the bit of the car that's designed to collapse, slow down that collision and make the time it takes for the person and the car to stop longer. It stretches out the length of the collision. And by stretching out the length of the collision, it means the forces on the people and the car are less. So we've got a crumple of the box. We know the starting momentum of the box. It's 8.7 kilograms meters per second. Okay, and we know how long it takes for the box to stop moving. 0.35. That's not the time for it to fall. That's the time for it to stop moving after it initially touches the floor. Okay, then it asks us to calculate the magnitude of the force exerted by the floor on the box. Okay, but it does tell us to use an equation selected from the list of equations at the end of the paper. So you're then going to turn around, you're going to dig around, and hopefully you're going to find the equation that tells you that force is equal to change in momentum. Just put one for short, change in momentum over time. Okay, and that is going to be equal to mv, which is the mass times the initial velocity, sorry, mass times the final velocity, take away mu, that's mass times the initial velocity. Okay, and then we've got that, all of that over time. Okay, then we know that the initial velocity, the initial momentum is 8.7 kilograms meters per second. So that's actually that. And our final momentum, that will the box stop moving. So your final velocity is 0, so that's going to be 0. So actually what we get is 0 take away 8.7 all over the time, which is 0.35. So you pop that into your calculator and you will get 24.86, or actually minus 24.86. And that's going to be newtons, because that's a force we're working out. You can say, can you have a minus force? Yeah, the minus shows the force is in the opposite direction to the movement. The box is falling down, the force is in the opposite direction. The force is pushing upwards, because it's stopping the box moving. So you could put in 24.86, or we can just put 25, because this is two significant figures, and that's two significant figures. So we can round it up just to 25 newtons. Yeah, but either would be fine. You can put the minus in, or you don't have to put the minus in, they're fine. It doesn't actually, it's not worried about that, because it's asking for the size of the force. Okay, it's asking for the magnitude. Yeah, and that word magnitude means we're not worried about whether it's a positive or a minus. It is a vector, so it is a positive or a minus, but it's just asking for the size of the number. So actually, if you just put in 25, that's fine. The next bit's quite interesting, because it says state. State the magnitude and direction of the force. Anytime the question is asking you just to state something, it means you know the answer already. It's not asking you to calculate anything, it just says state. And strangely enough, they haven't really given you much room to do any calculations either. There's only that tiny bit there. So the clue in the question is, the way they're asking it is they've already given you the answer. State the magnitude. It says state, you already know the answer. And guess what? If the force of the floor on the box is 25 newtons, well, we've got an equal and opposite deal going on here. The force of the box on the floor is also 25 newtons. What's the direction? but it's the force on the floor. So it's going to be down. Yeah, the box is going to push down on the floor. And that's how that one works.